Good. So we do hypothesis testing. In order to discover whether or not a certain data comes from a particular population, we choose one of the descriptive measures of that population and then to test if it is likely that the sample belongs to that population. For example, you may say that in BCom class, there's a student who's aged, say, on average, students are aged, say, 30 years. On average,
This is the heading I was
students
telling
are aged 30 years. So, if the average age was, for example, 23, remember, we said that among the disadvantages of mean, it gives one value. Somebody may say that indeed we have people who are 30 years. We have people who are 30 years. So we're going to conduct what we call hypothesis. You conduct what we call hypothesis testing. Now, hypothesis testing works like the following analogy that we're going to look at. I believe most of you know what we call when somebody has been accused of, say, a case, a criminal case. So when we have situations of criminal cases, let me just magnify, you'll have at the topmost, you'll have what we call the judge. So we have what we call the judge. Let me put that in the center and put him at 16. So then we have the accused. Then we have the prosecutor.
Yes.
Then we have the prosecutor. So we have two. We have the judge and then we have the prosecutor. Now, both of these will have to bring evidence. The accused will have to bring what we call evidence. The accused will bring evidence, and also the prosecutor will bring evidence. The prosecutors will bring evidence. We have the accused, then we have the prosecutor, and then we have the judge. So the judge, or sometimes we have the jury, sometimes we have the jury. Will always listen to the case, and then they will give their final verdict, and then they will say, basing on the evidence of the accused of the prosecutor, somebody is guilty. And we all know that in the courts of law, you're innocent until proven guilty. 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 So we have the judge, the accused, and the prosecutor. Likewise, this hypothesis tests also follows the same. We shall have the accused, then we shall have the prosecutor, then we shall have the judge, and then we shall Super Erin, you just type, I can read the messages. Then we shall have the conclusion. So, accused, we shall first state the null hypothesis. We shall first state the null hypothesis. H note, the sample belongs to the population. The sample belongs to the population. That is the accused. Then H1, the sample does not belong. These two, the prosecutor, these two move in different. I mute them. I don't know why they keep on.
Ten all, it's okay, right? What? 10 what? All.
But you don't have to make noise. If you feel that So, are they all muted? I think everybody now is muted. Everybody is muted. You didn't miss a lot. So we're saying that hypothesis will work with that principle where we have the and the prosecutor, then we have the judge. Then we have the judge. So, for example, we shall have three different types of hypotheses. One, we shall have when H naught mu is equal to 1 million. Remember, mu is what we call the population mean. Population mean. Population mean is called mu. And then, so we're going to be working with three scenarios. We shall look at a scenario where the first alternative, mu is less than. Mu is less than. This is the first alternative. Then we are going to look at a scenario where mu is greater than. Where mu is greater than. This is the second scenario that we're going to look at. Then we're going to look at a scenario where mu is not equal to. It's neither less than or greater than. Again, this works on a scenario where we have the judge, we have the accused, we have the prosecutor. The accused will have their witnesses or their evidence. The prosecutor will also have their evidences or their witness. Then the judge will decide who is guilty and who is innocent. And I said there are three scenarios. We have less than, we have greater than, then we have equal, not equal to. It's neither less than nor greater than. For now, it may not make sense, but as we go on, things will be clear. One-sided. So, one-sided alternative hypothesis. A random sample of observation. A random sample of observation. Today I'm extra slow because this topic requires a lot of attention and you need to understand. A random sample of n observation was obtained from a population normally distributed with a mean mu. So the population has what we call, the population mean is what we call mu, and its variance is what we call sigma squared. Now this is what we call its variance, and that is what we call sigma squared. If the observed sample mean, so the sample mean has what we call x bar, then a test of significance of alpha, we have that alpha there of the null hypothesis. So mean for the population is what we call mu. Mean for the population is what we call mu. Then the sigma for the population is what we call, this sigma is what we call the variance of the population. The variance of the population, the variance of the population, while x bar is the mean for the sample. X bar is the mean for the sample. X bar is the mean for the sample. So there's what we call the first hearing. There's what we call the first hearing, where both the accused and prosecutor bring out their evidence. So step one is what we call the first hearing. So we shall say mu is equal to mu naught. That mu is equal to mu naught. Alternatively, mu is less than mu naught. Then the alternative H1, mu is greater than mu naught. These two move in different direction. If H naught is saying less than, H1, the alternative should be saying greater than. So let us first leave the formulas. We shall come back to it. Let us first look at an example. Let us first look at an example. Good. The production manager of Mukwano has asked you to evaluate a proposed new procedure for producing its cooking oil products. The present process has a mean production of 80 units. What is that? 80 units. What is that? You can type the mean production of 80 minutes. What is that? What is that? That is what we call mu. That is what we call mu. 80 units is what we call mu per hour with a population standard deviation of 8. 8 is what we call the standard deviation, the variance of the population. The manager does not want to change to a new product unless there is strong evidence that the mean production level is higher with the new process. So the manager will only change, if the new process produces more. If the new process produces more. So this is 83. So the first thing that we're going to do is to state the first hearing. Let me just copy this. Sorry. Is to state the first hearing. So the first hearing is mu is equal to that. So the first hearing is that we are saying that the manager will only change if the new production line is giving us better lines. So we're saying the first hearing is that mu is equal to 80. Mu is equal to 80. And that is the first hearing, that is H naught. The prosecutor, which is H naught, let me first copy here. I don't want to go back to equations. The prosecutor is saying the alternative is mu is greater than, because the manager will only change if mu is greater than 80. If mu is greater than 80. So that is what we call the first hearing. And this is step number 1. Step number 1. This is step 1. So do we have any questions for step number 1? Do we have any questions for step number 1? How we come up with step number 1? It is from the question that the manager will only change to an alternative if it is greater. That is why we say that mu is greater than 80. Is that step clear? Is that step clear? You need to type. Barbara is saying it is clear. Okay, so majority are saying it is clear. Ephraim, just write. I can read. Just write. So mu is equal to 80. You'll get to know, we are going to do many examples. If you have not gotten it, just follow. That mu is equal to 80, which is the population standard deviation, and mu is greater than 80. Mu is greater than 80. Step number 2 is to get evidence of the accused. Step number 2 is to get evidence from the accused, and we get that one from the table. We get that one from the table. So we get that one from the table. Let me just increase on this and put it at 16, and then bold, then underline. Step number 2, we get it from the table. Now, reading the question again. The production manager of Mukwano has asked you to evaluate the proposed new procedure for producing its cooking oil products. The present process has a mean population, a mean production of 80 units. So that is our population, that is our mu per hour with a standard deviation of 8. The manager does not want to change to a new product unless there is strong evidence that the mean production level is higher with the new process. Suppose that the resulting sample of N is equal to 25 productions has a mean 83 at a 5% level of significance. Now, this is what we want. This is the 5% level of significance. And that is what we call our alpha. That is what we call our alpha. That is what we call our alpha. And we always give it to you. So we get this value from the table. We get this value from the table. So alpha is equal to 0.05. 0.05. Now, the nature of tables that we are using to read off that value, we need to subtract 1 minus 0.5. 1 minus 0.05. What answer do you get? What answer do you get? 1 minus 0.05. What answer are we getting? What answer are we getting? You give me the answer. So you have 0.95. 0.95. So I'll stop, then go to the tables. I'll stop, then go to the tables. Let me open the tables. I've given you 2 types of tables. I sent 2 types of tables. I sent 2 types of tables. There's one in Excel, then there's the other in Word. So for you, you're going to read that one in Excel. I mean in Word. It's the second table. It is the second table. It's the second table. It's the second table. Alpha is given. Alpha is given. Mastula, I don't know where you got that answer from. Alpha is always, the level of significance is always given in the exam. So I've given you 2 tables. Let me first explain those 2 tables. I've given you 2 tables. I've given you 2 tables, and they will be provided. They will be provided in the exam as well. I've given you 2 tables. You have 2 tables. Not so? Do you see my tables that I've attached? Can you see my tables that I've attached? So I sent 2 tables. I don't know whether the class representative forwarded the tables to you, because I told him to forward and they should be printed. Now, we are looking at table number 2. I don't know which calculator will give you these values. I don't know. It's there. You don't have to rely on it. Just learn how to read the tables. I'm going to teach you how to read the tables. Why are you using the calculator? Learn how to read the table, period. Because we may change. But the tables will never change. Read table number 2. We're going to read table number 2. Now, because I need to explain, I'm not going to use this table. I'm going to use the table in Excel. It's the same table. It's the same table. It's the same table as table number as the ones that you're holding. So I'm going to use that one in Excel because it will help me explain better. But it is the same table. It is the same table. Now, the value that we're looking for is 0.95, 0.95, 0.95, and we've gotten that value as 1 minus 0.05 to get 0.95. So the value that we're going to look for is 0.95. And we're going to look into these values, and we shall look for a number that is close to 0.95. 0.95. So look into that table and look for the number that is close to that. I'm going to do the first one, you'll do the second one. So if you look, the number that is close to that 0.95 is that value, 0.9495. Because if you round off that value, yeah, where I'm putting the cursor, if you round off that value, you'll get 0.95. You'll get 0.95. So I'll highlight that. Row. This is what we need. Yeah. So this is the closest value. So you read off the value that is here, which is 1.6. You read off the value which is there, which is 1.6. Then you add the value which is on top. So you'll have 1.6 plus 0.04. So it will be, if I put, it will be 1. Let me type here. It will be 1. This is equal to 1.6 plus 0.04 plus 0.04. So the corresponding value will be 1.64. 1.64. Again, I'm going to repeat. So you'll do for me different values that I'm going to give you, which is 0.04. The one on top, I'm going to repeat. Yeah, it corresponds to that value. So the value that we're looking for, you'll get 1 minus 0.05. 5% is given to us. So 1 minus 0.05. This is the thing that I'm explaining. I explained before, it is in the question. The question gives you 5% level of significance. So 5% is the same as 0.05. 5% is the same as 0.05. So you'll have 1 minus 0.05. So you'll get 0.95. You'll get 0.95. So after getting 0.95, you go to the table, look for the value that is close. Look for the value that is close. When I look into the table, the value that is close is 0.9495, because if you round off, you'll get 0. You'll get 0. What? You'll get 0.95. You'll get 0.95. So you read off the value on the extreme left, which will be 1.6. Then you'll add the value on the top. You'll add the value on the top. If you look at your tables, it's very clear. My table is a little bit, it moves, but you'll see that the two corresponding values where this value intersects are 1.64. 1.64. Any question? Because you're going to do for me like 3 of them. You're going to do like 3 of them. Any question? No, you don't take the table. You don't take the table. We shall provide the tables because you write in those tables. We shall provide the tables in the examination. We shall provide the tables in the examination. So if that is clear, kindly do for me. Find for me when alpha is equal to, you read the table. I don't know where you are. You're so absent-minded. I've explained that thing twice. Look for me, get for me when alpha is equal to 10%. 10% is equal to 0.1. 10% is the same as 0.1. So what is the corresponding value that we're going to look for? You'll ask those questions later. I'll explain. First, get me the value. Henry, first get me the value. The area under the normal curve is 1. The people asking questions that are irrelevant. The area under the normal curve, the bell-shaped, is 1. That is why we subtract 1. You understand these ones that I'm giving you. You have 0.9. 0.9. So get for me that value from the table that corresponds to 0.9. The value is equal to 0.9. So you'll have 1 minus 0.1, you get 0.9. Go to the table and get me that value that is close to 0.9. Go to the tables that you have. Go to the tables that you have and get me that value. We shall move with those who want to move. If you don't want to move, there's nothing we can do. Who does that answer is wrong? So like, why are you getting 1.208? Uh-huh. 1.29. 1.28 will pass, 1.28 will pass, and 1.29 will pass. So 1.28, 1.28, 1.28. So let me help those lazy ones who don't want to check. But the next value I will not. Next value I will not. So 0.9, you go back to the table. You go back to the table and look for that value. Look for that value that is close to that. So that value that is close to 0.9 is this value here. Is this value here. So we shall highlight. So you'll have 1.2, 1.2, and then you go up you have 8. So up you have 8. So it's 1.28, 1.28, 1.28, 1.28, 1.28, 1.28. Good. Get me when alpha is equal to 2.5. When alpha is equal to 2.5. Sorry. When alpha is equal to 2.5. When alpha is equal to 2.5. When alpha is equal to when alpha is equal to 2.5, when alpha is equal to 2.5. Get me the value that corresponds when alpha is equal to 2.5, the same as 0.25, the same as 0.25. So what is the corresponding value here? What is the corresponding value here? What is the corresponding value here? What value are we going to look for in the table? What value are we looking for in the table? 0.9, 0.975, 0.975, 0.975, 0.975. So what is the value? What is the Z table? What is the Z value from the table? What is the Z value from the table? 1.96. 1.96. 1.96. 1.96. So that is how we read the tables. That is how we read the tables. That is how we read the tables. So our answer is 2.02. You get that one. You write that one. Ephraim, you write that one. If it's what you've gotten, if it's what you're seeing from your table, you write that one. Let us who are seeing 1.96 go ahead. So that is how we get the step number 2. That is how we get step number 2. I've already done these things. That is how we get step number 2. That is how we get step number 2. So this was 1.28. 1.28. 1.28. So those are how we get the values. The last value, try when alpha is equal to 0.8, when alpha is equal to 8%. Try when alpha is equal to 8%. Try when alpha is equal to 8%. When alpha, alpha is equal to 8%. When alpha is equal to 8%. So Ephraim, you're putting it to 0.2. What is the corresponding value that we're looking for? What is the corresponding value that we're looking for from the table? You type. It's not available. Okay, don't worry. 8%. Chris, you give me that one. 0.92. Uda. We move. So go to the tables and get that value. Go to the tables and get that value. One. Shida was saying 1.4. What answer do I have? 1.41. 1.41. 1.41 is the correct answer. 1.41 is the correct answer. Mashtula, just add 1. 1.41 is the correct answer. So we go to step number 3. We go to step number 3. So that is the evidence of the accused. That is the evidence of the accused. This is the evidence of the accused. We need to get the evidence for the prosecutor. We need to get the evidence for the prosecutor. And the evidence for the prosecutor, let me just copy this. Step number 3, we compute and it is given like that. So X bar, we do it together, X bar. Our X bar from the question was 83. Our X bar from the question was 83, not so? X bar was 83 minus 80, which is our mu, minus 80, which is our mu, over, let me put, our standard deviation was what? Our standard deviation was 8. Our standard deviation was 8. Our standard deviation was 8 over root 25. N was 25. N was 25. N was 25. So calculate and get me the value. Calculate and get me the value. Calculate and get me the value. So Sevagala is saying it's 1.875. 1.875. Good. So this value is what we call Z computed. It's what we call Z computed, and it represents the evidence of the prosecutor. So I've already done this. Let me just delete, and we have that. We have 1.87. So step number four is where you summarize everything, and it's called the final talk of both lawyers and from both sides. They give their closing statements, and the judge makes the decision. So our first closing statement, we give that Z tables, the value from the Z table, our evidence was that 1.64. So let me make it red. And our value from the prosecutor is that value, So we have Z computed 1.875, and then Z from the tables, which is 1.64. Then it's going to have a, because these two move in opposite direction, then alternative mu is greater than 80. So we always begin with Z computed and say that since we follow, this is the last bit. Let me expand and let me make it bold as well. Let me make it bold. And let me make it 20. We say that since you always begin with the prosecutor, because it's the prosecutor that makes the first closing evidence, that since Z computed, I copy that, since Z computed, yeah, is greater than is greater than Z from the tables. Z from the tables is greater than Z from the tables, greater than Z from the tables, and that Z is equal to 1.64. Now you look at your statement. What statement is saying greater? What statement is saying greater? It is the alternative. It is the alternative. So this is the right statement. This one is the wrong statement because this one is saying less. I don't know whether you're following. If you look at these two statements, this is the right statement. It is saying greater. Yeah. And this one is saying less. So we reject the null hypothesis, or reject H naught. You can either put H naught or null hypothesis. Reject H naught. Reject H naught. Oh, sorry. Reject. We reject the null hypothesis. And concludes that the new, of course, the conclusion will have to go back and look at what you're doing here, because the manager does not want to change, which means the manager does not want to change to the new product unless there's strong evidence that the mean production level is higher. So, and conclude that we have evidence, and conclude that the manager can change now. How do you know how to reject? I've told you, you look at the statements. You say, since Z computed is greater than Z alpha, you look at these two statements, which is saying greater. It is statement number 2, which means it is the correct statement. So this one here is wrong. We reject it. So we reject H, not the null, and conclude that the new products. So that is what we have here. That is what we have here. So let me pull up my answer and you read. Good. So since H computed is greater than that, we reject the null hypothesis and conclude we have strong evidence to support the conclusion that the new process resulted in higher productivity. Even if you see, yeah, because now the new process is giving you 83. 83 is bigger than 80. So it means that this new sample that where the analysis was done is giving you better results, is bringing you better results. So if you've not understood, you'll understand with the second example. You'll understand with the second example because we're going to do 3 examples. Now, in this scenario, we've looked, remember, in the beginning, I said we shall look at 3 scenarios. We shall look at when alpha is greater than, when mu is greater than, and we shall look at when mu is less than, and we shall also look at when mu is not equal to. So we have completed this bit when mu is greater than, when the alternative is greater than. So we are going to look at when mu is less than, when mu is less than. So we shall go back and look at another example. We shall look at another example. And still, this is one-sided. Both greater than and less than are one-sided. Hey, please, you need to see the conclusion. Again, it is there. Good. Continue. One-sided alternative hypothesis. Now we're going to look at a scenario where this time mu is less than. And we said if mu is less than, I mean, if the alternative has mu as less than, the null will always be greater than because they move in different directions. They move in different direction. Again, let me go straight to an example. We'll come back to the formulas later. The production manager of Twin Forks Bearing Inc. has asked your assistance in evaluating a modified ball bearing production process. When the process is operating properly, the process produces ball bearings whose weight are normally distributed with a population mean of 5 ounces. What is that? What is that? Hey, you're right. What is that? What is this value here? What is this? That is mu. Good. Renamat of you in class. Others, I don't know. That is mu. And a population standard deviation of 0.5. What is that? What is that? Sigma. Good, Elizabeth. Sigma, good. A new raw material supplier was used for a recent production run, and the manager wants to know if the change resulted, and we shall not tell you whether it is greater than or less than. You have to read and interpret. Now here, a new raw material supplier was used for a recent production, and the manager wants to know if that change has resulted into lowering. Whenever you see those words like lowering, it means you're lowering in the mean weights of the ball bearings. There's no reason to suspect a problem with the new supplier, and the manager will continue to use the new supplier unless there's strong evidence that the underweight ball bearings are being produced. Underweight balls are being produced. Assuming that a random sample of 16 observation, what is this? What is that? Hey, N, Ruth, you're correct. N, but you need to share your answers with other people. That is N. Assuming that a random sample of 16 observation with a sample mean of 4.96. What is that? What is this value here? X bar, brilliant. At a 5% level of significance. So step one is to put the first hearing. Step one is to put the first hearing. So give me the first hearing. Give me the first hearing. H naught is equal to what? Give me the first hearing of both sides, the accused and the prosecutor. So today you go and tell your land colleagues that we've learned some law today in mathematics. Give me the first hearing. Hello, you type. I'll be able to understand. H1 mu is equal to 5. Mu is equal to 5. Lily, you're correct. How about H naught? How about H1? Mu is less than, you're right. Mu is less than 5. Mu is less than 5. So this is the first hearing. This is the first hearing. Mu is equal to 5. Alternatively, mu is greater than 5 because they're moving in different directions. Then the second hearing, mu is less than 5. Mu is less than 5. The second step is to get the value from the table. Remember alpha is 0.05. And the beta with this, we don't have to go to the table again. We don't have to go to the table again. Now there's a caution. There's a caution. If you're dealing with less than, if this bit here is less than, if that bit there is less than, whatever value, whatever alpha value you get, you have to put a negative value. For example, in the first one, we dealt when mu was greater than. We dealt when mu was greater than. We dealt when mu was greater than, and we just left it. We got 1.64 and we left it the way it is because we're dealing with greater than. But if we're dealing with less than, the only thing that changes is that we add a negative. We add a negative. So instead of saying that alpha is equal to, instead of saying that alpha is equal to 1.4, we shall put the z.64. 1.64. I know some of our friends have not gotten that one. Are we okay? Is that point clear? Elizabeth, as usual. So instead of putting 1.6, we put negative 1.6. Good. We go to the third step. Calculate for me Z. Calculate for me Z by filling in those, using this formula. Calculate for me Z using this formula. Z computed. Very okay, which is good. Calculate for me Z computed. Calculate for me Z computed. Calculate for me Z computed. We know our X bar. What was our X bar equal to? 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 What was our mu? Mu is what? Mu is equal to what? Ruth, you're correct. Ruth, you're correct. What is our mu equal to? 5. And what is our sigma equal to? What is our sigma equal to? Lily, you're first, but that answer is wrong. Sigma is equal to 0.1, and our n is equal to what? Our n is equal to 16. So you compute and get me the value. You compute and get me the value. Negative 1.64, 1.52. Correct. So for me, I've already done that. So we have Z computed is equal to negative 1.52. And members, the steps also carry meaning. You people, I looked at your, was it what? Introduction to business math? I don't know whether I taught you. And you miss steps, and it's not good. You put the steps as well. So we have Z computed. So we state what we call our closing statements. Z alpha is equal to 1.64. Then Z computed is equal to 1.52. 1.52. We state the hearing. We state the hearing of both. Remember, always begin with. Always begin with Z computed. We always begin with the side of the prosecutor. So we said, since Z computed, you put the value. Since Z computed, is it greater or less? Is it greater or less than Z alpha? Hello, is it greater or less? It is greater. If you don't know, go back to your Cartesian plane. Is greater than Z from the tables, than Z from the tables, than Z. So what do we do? It is greater. What statement does it support? Does it support the first one or the second one? Does it support the first one or the second one? Does it support this statement here or this statement here? The first one. Good. So it means the first one is correct. The first one is correct. The first one is correct, and that is our null hypothesis. But in statistics, we don't say we accept the null hypothesis. What we say, we fail to reject. We fail to reject the null hypothesis. It's the same thing, but in our language, you also have our language. We don't say we accept, we can never accept the null hypothesis. We just say we fail to reject. We fail to reject the null hypothesis. We fail to reject the null hypothesis. We fail to reject the null hypothesis. So that is why we have this statement. Let me put it there, and let me increase. Let me take it this. Since Z computed is that, let me increase the fonts. Oh, let me make it M20 for those people to copy. So since Z computed is greater than Z, we fail to reject H naught, the null hypothesis, and the raw material is not causing the lowering of the ball bearing. The manager will continue to use the new supplier. So the raw material is not causing the lowering. They're almost the same. We fail. So it is equal to is it clear? I told you this lecture will go slow. We do the last example. We do the last example and call it a day. We will meet on Monday for the last lecture. We do the last example. Anyway, I thought that part of anyway, this part is okay. We have the alternatives, and the statement is purely English. Chizungu choka. English, if you're good at English, then you're okay. You're saying that since Z computed is greater. Now, the second statement, the first statement is saying mu is equal to or greater. Mu is equal to. Then the second statement is saying less. So the second statement is wrong and the first statement is correct. But we do not say we accept the null hypothesis. We just say we fail to reject. We fail to reject it. But at the back of your mind, you know it is correct. We don't say we accept, we say we fail to reject. Good. We'll do the last example. I compare it with the first one. You'll go back and compare. You go back and compare because it's what we did. Edwin, let us go. Let us move. The world is very fast. Edwin, I compare. You go back and compare. You have your notes there. You want me to go back and compare for you, Edwin? Two-sided alternatives. You don't have it. You have it. You have it, Edwin. You go back. We've done it. You go back to the first example. It's what we did. It's what we've done, sorry. It's what we've done. First example that had what, 83? We stated them and said since 1.8 Z computed is greater, indeed it is greater. So the second statement was right. We rejected the first statement. We reject the null hypothesis and conclude. Wait, you continue. Two-sided. It's all about that. Mujuni. It's all about how you get there. So you know how to read, you have to know how to read the table because we shall not be using 5%. We can use another value. I can decide to use 78 to 78 from 78 significance value. So you have to know where to get those values from. And you have to know how to calculate those values. And this is a continuation of the past. So I'll show you how these numbers sometimes are set. Sometimes they can come as individuals, sometimes they come as a continuation of central mean and the measures of dispersion. There are some problems where the deviations are either too high or too low of equal importance. For example, the diameter of an automobile, the diameter of an automobile engine piston can be too large or too small. In those conditions, we consider the test of the null hypothesis, a random sample of n observation. So there are conditions where we need both. That is why we call it two-sided, where we need to increase or decrease, And let us first look at an example. Good. The production manager of Circuits Unlimited has asked for your assistance in analyzing a production process. This process involves drilling holes whose diameters are normally distributed with a population mean of 2 inches. What is that? What is that? That is mu. And a population standard deviation of 0.6. What is that? 0.6 is what? Sigma. A random sample of 9 measurements had a sample mean of that. What is 9 measurements equal to? Not sigma, sigma, n. So n is 9. Had a sample mean of 1.95. What is that? X bar. Use a 5% level of significance to determine if the observed sample mean is unusual, and suggest that the doing machine should be adjusted. Now, when they talk of adjusting could either mean you're either increasing or lowering. So it is two-sided. So it has both either, it has also less than and greater than. So the first thing is to set the first hearing, and we shall say mu is equal to 2 and mu is not equal to 2. Mu is equal to 2 and mu is not equal to 2. Are we okay with that bit? We don't say less than, we say not equal to. The alternative is not equal to because it has some little bit of adjustment. Now, sigma is divided into 2. Sigma is divided into 2 because it is two-sided. So the 5%, the 5%, will be divided into 2. The 5% will be divided into 2, and the value that we shall read from the table is that corresponds to 0.25. So the 5% is divided into 2. And when you divide, this, you teach us what makes sense. For me, I'm telling you it's not equal to. Why do you need to reinvent the wheel? It makes sense. That is what we do. That is how we do things. So we divide it into 2. We divide it into 2. And when we divide these things into 2, we shall have 0.025. 0.025. Who said it is 6%? Ochijawa. The answer is saying using a level significance of 5%. And you're saying it is 6%. Where are you getting the 6% from, Sebo? Wambali. Wambali. Don't confuse us. It is 5%. So you divide it into 2. So you'll get 0.25. And we got that value. We got that value when we were looking for other values. We got that value. We got that value from the tables. We got that value from the table. We got that value from the table, and that value was we got that value was 1.96. That value was 1.96. That value was 1.96. 1.96. 1.96. So we're going to have two values. Since we've divided by 2, we shall get a negative 1.96 and a positive 1.96. So this is how we state those values. This is how we state those values because they are 2. Let me highlight. This is how we state those values. Let me highlight because we need 2 of them. Because we need 2 of them. We need 2 of them. So that is the evidence of the accused. So quickly calculate for me the Z computed. 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 For me, I've already done it. I will not share my answer until I get your answers. Yeah, I'm waiting for your answers. Calculate for me the Z computed by getting X bar minus mu over sigma over root of n. Hey, several guys is saying negative 2.5. How else? So negative 2.5. Now, when you calculate your answer and you've gotten a negative value, you need to compare it with the negative, this value. Kakademo, because I know some people have not heard. When you calculate your answer, yeah, like we've done, and we get Z is negative, we shall be comparing it with the negative answer. If it is positive, we compare it with the positive value from the table. If it is negative, like we've done, we shall compare it with that. We shall compare it with that. That is what I've said. Eh? As a rule, for two-sided, always compare the negative computed value with the less than value from the table. So you do your first hearing. You do your first hearing. Pardon, I knew, but you first write. So we're going to compare Z computed, the negative with the negative. The negative. There's those people who always say, pardon. I said, when you compute and get a negative like we've done here, you'll compare it with a negative value. You compare it with a negative value. You'll compare it with the negative value. And you'll go back to the criteria, the decision rule that we used for negatives. And that's the decision rule that we used for negative was here. It's this, the second one that we've used. So you'll put the values there, the first hearing, you'll put the first hearing, Z is equal to negative 2.5, Z is equal to that. Then you'll put that because we are dealing with less than. We are dealing with less than. If it was positive, you go back and put the positive one. You go back and put the positive one because we are dealing with the negatives. So we deal with the less than. So that is what I've said. As a rule, for two-sided, always compare the negative computed value with the less than value from the table. From the less than value from the table. So we always we compare this and that. And we shall say that since Z, since Z computed, which is negative 2.5, since Z computed, which is negative 2.5, is it greater or less? Is it greater or less? Robert is saying less. Yeah, is less than. Is less than Z from the tables. Is less than Z from the tables. Less than Z from the tables. So what do? We do what? Do we fail to reject or we reject? We reject. Bella is saying we reject. Who else? Bella is saying we reject. Who else? Avangi, don't sleep. Who else? Reject. Fail what? We reject, because this statement is saying that statement number 2 is correct. It is less, it is less. So this statement is wrong. So we reject the null hypothesis. We reject the null hypothesis, and remember the alternative was not equal, which means it needs to be adjusted. We reject the null hypothesis. So let me just delete this. Is less than that, we reject the null hypothesis and conclude that the machine has to be adjusted. The machine has to be adjusted. The machine has to be. That is it for today. We meet on Monday for our last lecture. God willing, we meet on Monday for our last lecture. We meet on Monday for our last lecture. We meet on Monday for our last lecture. Alternatively, physical for what?